In this session, we're going to talk about vertical motion under the effect of gravity. The motion of a body in a straight line. We have studied 4 rules to find the V final from V initial and AT. A is the acceleration and T the time taken. And also S equals V initial T plus half AT squared, and S equals V final T minus half AT squared, and V squared equals V initial squared plus 2AS. We are going to replace the acceleration by the gravity in the threefold. So here, instead of V equals V initial plus AT, now V will be equal, V final equals V initial plus GT. Because the acceleration that effect on the body is the gravity only. And S equals V initial T plus half GT squared. We replace the acceleration by G. And S is equal to VT, V final, minus half GT squared. And the last rule, V final equals V initial squared plus TGS. What I did, I just replaced the acceleration by the gravity. Okay, in the 4 rules we have studied. I want to show you now something very important, which is called the positive sense. What is the positive sense? If we assumed that a body, if we are going to throw a body, and this body is going up, so here we can assume that this direction is the positive sense. Okay, so in this case, the gravity will be negative. The acceleration here, or the G here in this case, will be negative 9.8. Why 9.8 meter per second per second? Why is that? Because the gravity go downwards, and I assumed the gravity goes downwards, and I assumed that the positive sense is upwards here. So the gravity is 9.8 here in this case. So it depends on the positive sense. Here in this example, a stone is thrown upwards from the horizontal ground with a speed of 14.7 meter per second, assuming that there is no air resistance and taking G gravity, 9.8 meter per second. Find the time taken to reach the ground again, and find the maximum height reached. So we have 2 ways for answering this question, but I recommend to graph it. So here is the horizontal line, and the body is thrown upwards. So when we throw a body upwards, the body will reach a point here, will go up till reaching a point here. The V final here will be 0, and then will return to the same point. Okay. So here, assume that this direction is the positive sense. Assume that this direction here is the positive sense. This direction is the positive sense. Okay. And V initial in this case equals 14.7, because the direction meter per second here, because the direction of V initial in this way upwards. Okay. And when the body reaches the point here, the V final is going to be 0, then the body is going to fall down to reach the same point. So here, V final here, at the end of the motion, V final will also be 14.7 meter per second square. Meter per second, sorry. But what is the difference between V initial and V final? They are the same in magnitude, but they are different in the direction. So because the direction of the V initial is upwards in the same direction of the positive sense. So V initial is 14.7, but here V final is going to be negative 14.7. Why is that? Because the direction of V final in the opposite direction of the positive sense. So it will be negative 14.7. I'm going to write it here. Wait a moment. Here it's negative 14.7 meter per second. And the positive sense here is upwards, and the body is moving here in this direction. So the acceleration or the gravity here is positive. The acceleration here is positive. Y is positive, and the velocity decreases because I assumed that that is the positive sense. And when we reach the highest point the body can reach, and then we will go down, the body is going down here. So the acceleration here or the gravity here is going to be negative 9.8. Some people get confused and say, why is it negative? Why is it negative? Why? Because here the direction of the gravity in the opposite direction of the positive sense. The gravity here is going downwards, and here the positive sense here is upwards. So here S means the displacement, and when the particle starts here, it gains a positive displacement. And it loses it again. So the displacement is 0. I'm talking about the whole motion. The displacement is 0. And V initial in this case is 14.7 meter per second. And V final is negative 14.7 meter per second. And the acceleration here is negative 9.8. I'm studying the whole motion of the body from the starting point to reaching the ending point here, the same point. So the acceleration is negative 9.8 meter per second. And as I said, some people ask, why do we keep it as minus here? Because the gravity in the opposite direction, of the positive sense, we have assumed. So here we are going to use this rule, which is S equals V initial T plus half AT squared. And we are going to replace A by G, so S equals V initial T equals half GT squared. V initial T plus half GT squared. Don't forget that the displacement is 0 and V initial is 14.7 multiplied by T plus half multiplied by gravity. The gravity, as I said, is negative 9.8 multiplied by T squared. Then that is going to be 14.7 T minus 4.9 T squared equals 0. Then take T as a factor here. So you're left with 14.7 minus 4.9 T equals 0. Then we have two solutions, T equals 0. And the second time, the second solution is 14.7 minus 4.9 t equals 0. So t equals, divide 14.7 by 4.9, it will be 3 seconds. That's it. Let's analyze it. When going up, the V initial, let's study going up only. V initial is 14.7 meter per second. And V final, I'm talking about V final when reaching the maximum point. So we are studying now the going up of the body or of the stone. So V final here in this case is 0. Because anybody, if you are going to project a body upwards, the body will reach a point. And this point, the velocity is 0, and then the body is going to fall down again. So the V final is 0, and the acceleration or the gravity. The gravity is negative 9.8. Why negative 9.8 meter per second per second? Because the direction of the gravity is downwards, and the positive sense or the movement is upwards. So here it's up. I assume that the positive sense here is upwards, and the effect of the gravity is downwards, so it will be negative. The body is decelerating negative 0.8 meter per second per second. So it's not acceleration, it's deceleration. So it's negative 9.8. The velocity of the body decreases along the time. So here we need to get the time. We can apply this rule: V equals V initial plus AT. Then replace A by G. So V equals V initial plus GT. And then substitute V initial 0 equals V final is 0, and V initial is 14.7 plus GT, which is negative 0.8 multiplied by T. Move it to the next side. Then 9.8 T equals 14.7 divided by 9.8. So T equals 14.7 divided by 9.8 equals 1.5 seconds. That's the time of the ascending, the time of the ascending of the stone. And the time of the descending of the stone will be 1.5, and we can study the going down. We can study going down of the stone, the going down of the stone. So in going down, S, I don't know what is S, and V initial is 0. Why V initial is 0? Because the body starts its motion from the rest. So V initial is 0, and V final is 14.7. And I'm assuming that the positive sense here is downwards and going down. So in this case, the acceleration G is 9.8 meter per second per second. Okay. So we can use this rule, which is V equals V initial plus GT here in this case. So 14.7, the V final, equals V initial 0 plus 9.8 multiplied by time, divided by 9.8. So 14.7 divided by 9.8 equals T time. So time is equal to 1.5 seconds. That's it. That is the time taken in the descending. You know, I split that into two parts. The ascending of the stone and the descending of the stone. The going up and the going down. It agrees with what we have got in the previous solution. How can we get the maximum height? You know, to get the maximum height, you know that V initial is 14.7, and V final is 0. I'm talking about the going up only. And the acceleration is negative 9.8. And the time is 1.5 seconds. Okay, so V squared equals V initial squared plus 2AS. So 0 squared equals V initial squared 14.7 squared plus 2 times the acceleration is negative 9.8 multiplied by S, the displacement. So from that we can get the maximum height S is 11.025 meters. That's the maximum height. So to get the time taken, to get the highest point, V equals V initial minus GT, and V final is 0 in this case, equals V initial minus GT. Move it to the next side, so GT equals V initial. So the time taken, or the time taken to get the highest point, is equal to V initial over T, T over G. So the time taken equals V initial over G. We use this rule directly to get the time taken to get the highest point, or the maximum height. And to get the maximum height, we can use this rule: V squared equals V initial squared minus 2GS, and the maximum height here is S. And V final squared is 0 equals V initial squared minus 2GS. Move this to the next side, so 2GS equals V initial squared divided by 2G divided by 2G, cancel them out. So S is equal to V initial squared over 2G. Now compare between them, you will get here T is V initial over G, and the maximum height is V initial squared. We put 2 above V initial over 2 multiplied by G, and this 2 here is multiplied by G. So we observe they are close enough to each other. T is V initial over G, and S, the maximum height, is V initial squared over 2G. I hope you enjoyed this session. See you in the coming episodes. Goodbye.